Awesome. Thank you. I'm Matt Flug. I'm an analyst at IDC. I cover WebAssembly and application platforms in general for IDC. And I have the pleasure of talking with you all today about WebAssembly's journey beyond the browser. It's technology I'm pretty passionate about. I think it's pretty cool and it does some cool things. We only have 15 minutes, so if there isn't time for Q&A, I'll be around here. Feel free to just pull me aside, ask me questions, or not. Either way. So before we talk about WebAssembly's journey beyond the browser, let's quickly talk 101 about its history. Wasm is the abbreviation for WebAssembly. You'll hear throughout the talk a lot of Wasm, a lot of WASI. Everything in the WebAssembly ecosystem is named on a variation of something like that. So it was originally proposed by engineers from various companies, Google, Microsoft, to be a portable binary format of code to enable high-performing web applications. The binary nature I don't think I need to explain to a lot of you, but it compiles into a compact, kind of low-resolution type of code called bytes, and those can then be compiled into a Wasm module. The bytes are a lot smaller than human-readable code, so they are easier to transmit, execute, load, and that's kind of what enables that scalability for Wasm. The benefits of Wasm on the web are lightweight architecture, portability across platforms and browsers, and polyglot nature, so can do a lot of languages. And then each Wasm module is inherently in a sandbox secure environment. So those kind of attributes are what's driving its growth beyond the browser into cloud-native development and AI. So, Wasm today. There are now runtimes like Wasm Time, Wasm Edge that allow the compute of WebAssembly to run in the cloud and at the edge. In 2023, there was a standardized set of APIs called WASI, which was a major milestone for WebAssembly. And that's because the sandbox nature of each Wasm module, it needs a specific API to connect to anything outside of that sandbox environment. So to connect to any external services, to connect to any other Wasm module, you need a WASI API. Once that happened, there were open source companies like Cosmonic and Fermion, if any of you have heard of them. They started coming out with Wasm-based application platforms. And they have some pretty big news this over the course of this past year. And then another company called Fastly. I was actually just at their event. Cool story about them that I'll tell, but they are a serverless application platform. They have a foundation as a secure CDN, and their compute service is built entirely on WebAssembly. That enables them to boast pretty impressive speeds, low latency, and also powers their security-focused posture. At their event, who here knows Shutterstock? Images, stock images, videos. I thought that they were dead and gone. And I definitely thought that they would be dead and gone with ChatGPT, Gemini, all those image-generating AI tools. They noticed that the leading LLM providers were going into their data centers and training the LLMs without their permission on their massive data set, petabytes of data. So they had a business decision to make, right? They could either die or figure out how to monetize this. So they actually said, okay, we're going to sell them this data. They're going to get a better outcome because we're going to cooperate with them. But we need a way to transmit it securely at scale and quickly, often in a time of like 6 days, right? That's 30 petabytes of data was the largest amount that they had to transmit. They went to RFI to see who could do it. They were an Amazon shop. The only company that said, hey, we can do this, no problem, Fastly. And it was all because of that WebAssembly. So Cosmonic, they recently released a commercial offering. It's the first commercial offering of WebAssembly as an application platform, a control plane for Wasm applications. And then a pretty cool thing, Fermion partnered with Akamai Everyone knows Akamai, I imagine. They partnered with Akamai to kind of solve the problem of cold starts in Akamai's serverless architecture. It's a problem that's plagued all serverless, all functions since its inception, and that's a big use case for Wasm, as we'll see here in just a second. And then at the end of 2024, the US government actually did some research. They wrote a paper. You can go check it out. I have the link there, where they recommended the use of Wasm in protecting data in transit. And that's the exact use case for Shutterstock, right? Not only does it enable the low latency, but also the security of that data as it's transmitted, and that's going to be more important as with RAG applications, with multimodal applications. It's going to become a crucial thing. So I could talk to you about stories and all that. IDC, International Data Company, that's what we do. I do have data. So we ran this survey at the beginning of the year, and 89% of the people that we surveyed said that they are planning to or already using Wasm either on its own or in conjunction with containers, Kubernetes, or serverless already in cloud native development. And then the benefits of Wasm. I kind of highlighted them at the beginning, but proof is in the pudding, right? Real data. Security enhancements, improved scalability, faster startup times, and resource efficiency. There are some other ones there too, obviously. It enables a web strategy. Hybrid and multi-cloud is a big thing for cross-platform portability. But that sandbox environment, that's, to me, the most important thing, especially as we get into the era of agents. I'll tell a story here in just a second of how Wasm could have prevented something that just happened. So, the future of WebAssembly. It's still a very much an emerging technology. There are not a lot of users of it. It has some really cool potential. It does some really cool things. It's not going to replace Kubernetes, containers, serverless, virtual machines, just as containers and Kubernetes didn't replace virtual machines. So, but it will play a role as we move forward. So, current and future use cases for WebAssembly. This is a bit of an eye chart. I try not to put this many words because I don't like to read that much. So, but albeit, the theme of WasmCon 2024. WasmCon is a co-located event at KubeCon every year. They have it. And the theme last year was better together. So using WebAssembly in conjunction with containers, Kubernetes, and serverless, and how it could make those architectures more efficient. So Wasm modules can run inside a container. They can run alongside a container, or they can encompass a container. They can do the same for clusters. So if you run your cluster or your container inside a Wasm module, you get that inherently sandbox environment. It compresses it down into a more lightweight architecture and makes it more efficient. And you can also integrate the runtimes, so Kubernetes can schedule and manage Wasm workloads, and then developers can mix Wasm and containerized services within the same cluster. Cosmonic, I was talking to their CEO, and he kind of put this in perspective for me, right? It becomes really powerful when you think of the Wasm modules as Lego blocks, right? So let's say you have a data application. You want to build a data application to analyze data in your data center. Maybe Python is the best language to do that, right? But you work at Bank of America or Fidelity. They're probably using C#+ or C++, sorry. You can write that application to analyze the data in Python and then build another Wasm module in C++, put it together. Now you've got a really powerful business application that meets your enterprise requirements. The biggest thing with serverless is cold starts. In the same survey of the data that I showed, I actually should have included it here. The biggest problem with serverless that people told us was cold starts. Wasm does help solve that. It's actually the reason Akamai partnered with Fermion. And then AI and agentic workloads. RAG, anything that you can't have latency for, that's going to be important. Wasm can play a role there. And then the Shutterstock use case is really cool. Um, just being able to transmit that amount of data securely, quickly, at scale, and it actually saved the company, right? I mean, they would have died. I thought they were dead already, but they would have died for sure. And now they're making hundreds of millions of dollars selling that data. So what can you do today? Pick a supported language for WebAssembly and start building. It's open source. They have their stuff on GitHub repos. I put the community link there. I have more stuff on the next slide. There's a Discord chat. There's a Reddit chat or Reddit thread. Sorry, I'm a little older. And then here's some resources. So you've got the community page for WebAssembly. You can go to contribute. Wasm Cloud is the open source project for Cosmonic. They're doing some really cool things. And then people to follow on LinkedIn. The Cosmonic folks and Matt Butcher is the CEO of Fermion. He taught me everything I know about WebAssembly. And he's a really cool guy. If you ever get to meet him, or he will be at KubeCon if any of you go, he's awesome, very passionate about this stuff. And then the Cosmonic folks have a weekly meeting for Wasm Cloud on LinkedIn. You can just go watch it. You can join it. You can go watch it. So very cool. Bailey Hayes, also great, very smart. She's like, I think she built WASI pretty much by herself. So that's it.
So you can compile to Wasm from a wide range of programming languages, I'm assuming. So containers have sort of their own view of like the operating system, like their networking and files, processes, and so on. And when you need to send an HTTP request, for example, you need to access the network. So how does Wasm handle that?
Yeah, so I believe there is a WASI API to access those networks, and you would just connect it to the network that in your operating system. So if you use OpenShift or use AWS, you would just connect the Wasm module to that service.
Okay, so there's some sort of bridge.
Yes, yeah,
And
yes.
that's the WASI API?
Yeah, I believe that. So WASI is like a framework of APIs that are purpose-built for WebAssembly modules. They are built to connect the WebAssembly module to external services or to existing WebAssembly modules themselves. So, and I believe that is how they do it.
Okay, yeah, that answered my question. Thank you.
So I don't know a ton about WebAssembly other than having heard about it over the years. So you're boasting the performance gains from WebAssembly, and I'm just what is that in comparison to? Is it like JavaScript in serverless applications? Is that because you don't have a compile stage, when starting an application? Is that where you think these performance gains come from?
So it is comparison into Java or really any other just language and framework. And I think it's because it's so lightweight, right? It's not human readable code. It's compiled into this very lightweight architecture that it can just spin up in a second, or less than a second, as Cosmonic or Fermion will tell you. And I think that's why it kind of just makes it so much smaller that in order to get going, it doesn't need to do as much.
Okay, and you gave an example of Fastly using WebAssembly to be able to transmit data very quickly. Do you know what properties of WebAssembly enabled that?
Yes. Well, to an extent, and I should have probably asked them that question when I was there last week. So I will ask them. But I would have to imagine that it was everything is compiled again to super small, and it reduces the resources needed to kind of get stuff going and get stuff across. So I think just compiling it and using that power, you don't need as many resources to generate that power. I should ask them that,
Yeah.
and I will. I know that's not a good answer.
All right. Thank you.
Hi. So we're seeing more and more Wasm outside of the browser, and one of the main strengths of it was its ability to modernize a lot of old legacy systems and get them on in the browser. So I'm just wondering, like, why Wasm is going in this direction instead of being adopted in modernizing old systems.
I think people do use it for that, but it's in order to do that, so you would need to refactor that application, right, to modernize it, and then there's just another step of compiling it to WebAssembly after that. So I think I see it and I hear about it. We have data that says it's being more used in net new cloud native applications, and I think it's because of that extra step, right? And there are things like now you need to build it so it can be compatible with WASI APIs because not everything is, right? Those are purpose built for WebAssembly. So I think it could be powerful in doing that, but now you have tools like, I think Red Hat has one. I know Microsoft does where it could just refactor the application for you and modernize it. So I think there are other tools that may be better to do that. Once it's time to run that application, I think that's where WebAssembly comes in.
So my question is, with WebAssembly escaping the browser, basically, do you see any use cases where, in the near future, organizations, companies, people who are developing end-user applications might start developing cross-platform applications in WebAssembly, and then, for example, you've got an application written in WebAssembly that then is distributed on both like the Google Play Store and Apple's App Store. Is anything like that around the corner?
Yeah, I mean, I think we're seeing a rise in multi-cloud and hybrid cloud. I should have included that too. We have data on that. And I think that as organizations kind of embrace that, we're eventually, and I don't think it's around the corner, but I think we're eventually going to get to a state where it's like, okay, I want to run on AWS on Tuesdays from 10 a.m. to 1 p.m., and then I want to switch to Microsoft, and maybe I want to have stuff running on Broadcom, right, in private cloud, or Red Hat. And so I think we're going to get to a state where organizations realize, hey, this technology is going to allow us to kind of just switch. We won't have to refactor from AWS to Microsoft to Red Hat. We'll just be able to kind of switch over those applications. This technology will do it. There's other technologies popping up that are doing it, not with WebAssembly. I don't know how they do it, but I think they just refactor automatically for you. But yeah, I think we will get there. Around the corner, though, probably not so much. Probably when I have more gray hairs.
Thanks.